All right. Welcome back, everyone, to the Friday Hack Hours. We are currently in a second tutorial about xarray. And xarray is the foundational package for working, especially with gridded data in Python. And today we're going to be learning about using xarray with OPeNDAP. If you missed last week, here's last week. Last week I did an intro to xarray, and in that one I showed using xarray with NASA Earth data netCDFs and using cloud storage data. You can watch the video on that here, and then if you click here, you'll see the tutorials that I went through. I went through some of the really basic things that you do with xarray, subsetting, creating data cubes, and creating things like monthly averages and seasonal averages and spatial averages and all that. As I went through last week, xarray is part of the Pangeo ecosystem of tools for working with big Earth data. It was originally developed by the climate Earth data community. xarray actually can work with any kind of data that has basically this shape where it's a type of like cube of some sort. It doesn't have to be a regular cube. It can also be like swath data, irregular cubes, definitely. A very key aspect of xarray is that it is integrated with Dask, and Dask is something that under the hood is taking care of your parallel computations. So this makes xarray really fast for doing things, and it doesn't blow up your memory. You don't have to load all the data, which may be petabytes or terabytes, many gigabytes of data into memory. All right, so today we're going to see how to use xarray with OPeNDAP servers. And let's see here. Hopefully I got this link going so you can find it. Work? Nope, didn't update. That's okay. So let me send you the put the link in the chat. Okay, where's that chat? Here it is. Okay. So this is the page that I'll be on. I'm going to be going through some material from last season that I developed, updated a little bit to work a little better with Colab for today. So we're going to be working again with Colab, and we'll also be loading some data still from NASA Earth data, and I'm going to talk a little bit about like how you deal with authentication issues, because honestly, that's really the hardest part about working with OPeNDAP servers, is how to deal with that authentication step. And I'm going to kind of walk you through that, so you will have seen it if you want to be getting data off of OPeNDAP servers. Okay, so let's go back here. So the first one that I'm going to start with is this simple example. And so this, I'm starting off with an example where I don't need to authenticate. And let me put this in here. You'll find it in the left of the link that I put in the chat, but I'll give you the direct link here. So this is the tutorial that we're going to go through first. And at the top, there's an Open Collab. We're just going to use that to make it simple so everyone can go through that. If you're on our Jupyter Hub, you can also click there. Everything's set up in there. And I mentioned this before. Our Jupyter Hub is to help you learn how to use all these tools. It has everything installed. All you have to do to get on it is reach out to me, eli.holmes at NOAA. I will say it's for anyone at NOAA. So if you're at NOAA, reach out to me and I can add you. But like I said, I'm going to do through Collab because we have a variety of people online and I want to make sure everyone can run through this. So, okay, OPeNDAP. So this is a type of data server, thread server, where you can access data and stream that data. Thread servers will provide multiple ways to access data, and one of those is via a OPeNDAP protocol. And a nice thing about OPeNDAP is that it allows you to subset the data and get chunks of the data instead of downloading the whole data file. And so now we're going to use xarray to interact with data that's on an OPeNDAP server. So the first thing that you need to do when you're interacting with a OPeNDAP server is to get into their catalog and poke around a little bit. So like if you were, you're trying to access some data and they say, data access, and then they'll mention, usually they'll say threads, but they might say OPeNDAP. You're going to click on that and you need to orient yourself a little bit. So let's go ahead and click on this one. Okay. So let's orient ourselves and we're going to go back a little bit here to orient ourselves. Oh, actually, I want to go even further back. Let's see. Let's go back here. Let's see where this takes us. Data. Let's see where that takes us. It's not taking us anywhere useful. Let's see, predict climate. Okay, that's not very useful. So if you were to poke around on their website a bit, you would eventually see something that would talk about their thread server. And then if you click on there, you're going to see this catalog. And here you begin to guess, aha, they've got some data sets. So you're going to look at those and you can see that they have lots of different data sets. And often you're going to have to use some other documentation to understand these data sets. So often this is just the data. We're going to see some other examples where we will be able to get a little more information from the catalog. This particular one, they're just showing us the files and the file structure. But that's important because we can kind of poke around. This is a reanalysis product. It's a climate model. And we're going to look in this case at surface variables. And if we had researched about this data, we would know that this is, actually, I don't know off the top of my head, which one are we looking? We're looking at air sig. And I can't tell you off the top of my head what air sig is. Obviously, it's something to do with air, but I forget what the rest of this signifies. Anything else? Let's say we know what that is. We can see .nc, it's a netcdf file. And importantly, what we want to do is we're going to click on this. We're still trying to understand it. And aha, okay, we've got a little more information here. And now we see we've got this OPeNDAP link. tells us it's going to access via OPeNDAP in the DAP2 protocol. Great. So that's something we're going to be able to stream that data using xarray. So we're going to click there. Let's click there, see what we've got. Aha, now we're really getting somewhere. So this also tells us a bit more about the data. That's good. Yes, air. What are we looking at? Air temperature at sigma level 995. Okay, there we go. So it's getting it's 4 times daily air temperature at sigma level. This suggests to me that these are probably pretty big files. Because I noticed they were yearly. So this is yearly, daily, 4 times a day. Pretty big. This data URL is what we need. So we're going to go ahead and copy that. Now we see this. So that's what the URLs look like. And so we kind of now know the format of the files on this OPeNDAP server. We're working on Colab. I'm going to go ahead and set things up here. Anyway, so I need to, these are the engines that are going to be able to communicate with an OPeNDAP server. If you didn't have these installed, what you would see is a very unhelpful error that would say file not found. And the file is definitely there. It's just that you didn't have the engine for it to be able to read it. That's kind of a tip, is that a lot of times when you're like trying to access data that's in like a data server, the errors don't really tell you what the actual problem is. And the first thing you should always guess is that you didn't have the right engine installed. This is a really common engine, so you always want to make sure you have that. And then if you're working with OPeNDAP, often you want to add on PyDAP. Okay, so I'm going to import the xarray package. So run that. And now what I'm doing here is by scanning over those files, I have an idea of what the files look like. And what I'm going to do is use Python here, using kind of a for loop to get a vector of the file names. So let's do that. So what we see here is that there are 77 years of this surface air temperature from 1948 to 2025. Let's look at one of these files. There we go. And that's the URL that I was able to see from the website. So that's good. And now, fingers crossed here, see if it opens up, and it opened up. So lickety split fast. It's not actually loading the data into memory. It's lazy loading it. It's loading the information about the data. And as I said, this is yearly data daily, 4 times a day. So lots of time points. Not much lat and lon. So I'm guessing this is either it's not global. I guess we'll find out in a moment if it's global. It's definitely got big grids if it's global. Okay. So let's load in all the data. So all 77 files, and create a data cube from that. See how that goes. Fingers crossed here. Notice that the command changed. Instead of open dataset, which would be for one URL, I now say open MF dataset. Oh, it crashed. Oh, gosh. It didn't work. Oh, no. Why did you crash? Let's see here. Oh, now I really crashed things. Darn it, darn it, darn it. That's really unfortunate. Okay. I may have to jump over into the Jupyter Hub to debug this. It may have. Yeah, I'm not sure what it's doing. It may be maxing out the memory there. We can definitely. Hey, whoa, it worked. Amazing. It didn't like the parallel for some reason. Okay, there we go. Hey, great. Yay. So it worked. So now you can see lots and lots of time steps. We say we have the error variable. So now we have this object and it's all the metadata, all the information about it, and we can do things with it. So let's make a plot. So what are we doing here? ICEL means we are selecting by an index. So rather than saying a particular date, ICEL just says take the, in this case, the first one. Wow, that wasn't very interesting. Oh no. Oh, I bet it didn't actually get the data. Yeah, darn it. Okay. When I was testing earlier, I did have a little bit of trouble with hitting the PSL data server. It did keep returning NAs, which is what happened. What we were seeing there, it's all NAs. Let's see if this other one worked. Okay, there we go. So it's this parallel one, the OPeNMF dataset. I don't know why it's having trouble. I also had this trouble on the Jupyter Hub, and I'm guessing it's something about the OPeNDAP server throttling me as I'm making a whole bunch of parallel requests. So what I did to get around that is I just loaded one file. So I went back and I ran this code here to get one file. And then I was able to take that one, which is this DS. Let's take a look at this. Let's do DS. This is a type. So DS is what when I loaded the file using xarray, and what you can see is it's a xarray data set. And I can take that and I can do things like select a particular time period and plot. And what's important, one of the things that's important here, I'm not able to demonstrate this next part on the Colab because, as I said, the server is throttling me, and I wasn't able to debug that quickly enough. But I'm going to walk through and kind of tell you talk through the next steps. So let's say I could have loaded all these and it was not returning NAs on me. Let's see here. I mean, it's going to return NAs, but maybe I can still. It's just throttling some of it. And I noticed this before, like some of them are all NAs and others aren't. Let's see here. So it picked up the structure of it, but it's not getting all the data. Let's see. So probably BNA. See what happens. Okay, so it's kind of hit or miss. I'll keep going and working through it like this, but you'll see in a moment that some of the data it returned was NA. Okay, so this data set is really large. It's not like monstrously large. It's 4 gigabytes, but if I were on a really small virtual machine, it would still crash it. But the way it's working is that it's not loading it doesn't have to load all the data into memory. It's going to be working with subsets of it. So like if we ask it to do task, it's kind of working chunk by chunk, so it won't crash our memory. Okay, so let's go ahead and do some things with this. So we showed this last week, how you can take means across dimensions. So in what we're doing here is we're taking the air, that variable, that's how we denote that. We are selecting 1949. I loaded all the years, so it has all the years 1948 to 2005. And I'm going to take the mean across the lat and the long dimensions, and then I'm going to make a plot of that. So, oh, come on. Why did you do that? Okay. It's probably gonna be mean here and not do it, but we'll see what happens. Yeah. Let's pick a different month, a different year. Let's see if we have a different. This was one of the years where it's all NA. See how it works. No, I'll try one more and then we'll keep moving along here. Ah, darn it. Okay. Okay. Well, that is really too bad that it keeps returning NAs on us. So let's see. Well, I guess I'll talk a little bit about this, but I'll move on to an example where it's not returning NAs. There's something going on with its with their server, unfortunately. Okay, so one of the things that we can do when we're working with xarray is we can tell it to chunk our data in different ways. If we look at our data set, so I loaded in all those years, and we can say, hey, how have you broken up this data? And so if I run that, it'll tell me this. And kind of scroll through. And what this is this is how the time is chunked. This is how the latitude is chunked, and this is how the longitude is chunked. So what that means is that it's chunked a whole year together, and it's all the latitudes and longitudes. So it's honestly a pretty big chunk. And if we needed to do something in parallel, we'd probably want to make those chunks a little smaller. And what you can do is you can change the chunking of your object so that when you're doing really big tasks, it'll make it do it in smaller little pieces. So in this case, what I could say is, okay, I want you to chunk it in 24 segments, so 24 6-hour segments, and use all the latitude and longitude. So you can do something like that. So here I've chunked it, and now what it reports is that the whole array is like that, but now I have these little 1 megabyte chunks. And that's important when you try to do things that are really big. So if I wanted to get the mean across all latitude and longitude for all 77 years, if I tried to do that, it might really bog down whatever computer that I'm on. Usually when I'm teaching, I'm in pretty minimalistic little virtual machines. And so I need to be very careful about memory. And so chunking like that allows you to kind of chug slowly through a problem, but never blow up the memory. Okay, so it would take about 4 minutes to run that, but we could get this like that, all that. And then we could do resampling, all those kind of nice things that I was showing last week. Okay, so let's leave that example. Let's go to another example. Fingers crossed this other example won't be problematic. Okay, let's go back here. Okay, let's go back. Okay. So, new example. Let's see here. We're going to show a, this is, we're going to be looking at a ROMs example. So this is, we're getting some regional forecast, sort of these, ocean models. In this case, you can see here it's predicting, in this case, potential temperature. Okay, so let's go ahead and run that one. Fingers crossed here. So same thing, I need to close that. Colab might be unhappy if I have too many of these open. And then we need to, once again, make sure we have NetCDF and PyDAP installed. So I'm going to go ahead and install that. Come on. Taking its time. All right. Okay. So I'm going to import xarray. That's important. And now let's make sure that works. Okay. So let's see here. We can go to this. Let's see. Yeah, okay. So again, this is what a thread server looks like. And, often when you're working with these, you're going to be poking around at them, looking at, okay, here's the model I want, and then kind of poking deep into it and taking a look at, at the file structure. And then, you're clicking on the URLs and that takes you to, a page like this. I'm sure there's a way to get directly to this page, but I personally am often poking around on the files like that. And I've poked around on a lot of thread servers, and it often feels to me that's how I'm kind of getting to these kind of pages. And once you get on a page like this, and if you can get to that OPeNDAP server, usually that'll get you someplace where you have something that feels human readable like this. This is where, when you're working with OPeNDAP servers, this is where you'd like to get to, because this first off is telling you about the variables, but importantly, it's giving you that URL. And that URL is going to be a standard format across all the files. So in this case, I'm looking at a particular model here. Okay. and all the files will look kind of like this. And here I've, told it, go look at this thread server, get this, and how did I come up with the code? Well, I was looking at those URLs, and then I probably asked a chatbot, hey, here's the format. I want to get all these files. And I'm showing you this because I think this is actually one of the hardest parts of working with data on OPeNDAP servers when you're working with xarray, is figuring out how on earth do I get these URLs that xarray can load. And the way you're doing it is you're trying to get to this page, and then it will show you that data URL, and that's what you want. So let's go ahead and see how this works. Fingers crossed. No, again. Now what? Are you not liking parallel? Okay, I may have to switch to the Jupyter Hub. So this is really me a hard time. Okay, seems to be chugging along. Okay, there we go. All right, so now we have our URLs. I loaded 4, so I have 4 time points. The Y dimension, the X dimension, it also has depth. Very good. Let's see how big these are. They're about 100 megabytes. Let's fingers crossed here, see if we can plot. Check. And there we go. Actually, it worked. So it went and got that data off of the OPeNDAP server. It plotted for us. Let's see what we're doing here. This is the dataset object that we loaded right here that it's showing us. This is the command. I'm opening 4 files at once and creating an object with 4 time points. And it has, let's look here. So you can see the coordinates that it has as time, depth, latitude, longitude. I am going to plot temperature. So this is how you can select a variable. You can do dot, and its name is temp. So that's what's going on. I'm selecting the temp variable right here. Take a look at the coordinates of that. It's got time, depth, NY, and NX. So here, what I'm going to do is I say I'm selecting the first, well, it's actually starts at 0. So this would be the second depth. I'm selecting the second time. So now that I've selected these 2, I then have something that's X and Y. X and Y. And now that I can like plot like a map. And now I say plot, and I look at this. I can also see that it has these coordinates, longitude and latitude. They're appearing here, coordinates, and my X and my Y refer to that. And so I can say X equals longitude, Y equals latitude, and that's how I get this plot. Let's see if this part works. Okay. So here, selecting temp, I did it a different way so you can see both ways. People alternate between these 2 ways of getting the variables. Here I said square brackets, quote temp. That's another way to get the variable. I cell means I'm selecting the second depth. So I'm going to get a time series for that depth. And now I'm applying the mean, and you can designate what dimensions you're applying it over. So I'm applying it over the Y and the X. I'm taking the average over all the Y's and the X's, compresses that, collapses that. And what I have left are the time points, the 4 time points. So here you can see this is a time series now of the temperature, the mean temperature over this entire grid. Let's see here. Okay. So here I want to take a little point here, and I want to take a time series in this little box here. So I'm going to, I'm just making a little plot here and creating this little bounding box, and I'm plotting it. That's all I did there. And looks like I was doing some fixing with the coordinates. And now what I'm going to do, so what I'm doing here is I want to slice this by this new thing that I've defined. And okay. So why did I just do this? Well, if you go up here, what you'll see is that latitude and longitude are actually two-dimensional grids. It's two things, a y and an x, a y and an x. So if you wanted to slice something, so pick a range, that's only going to work on something that's one-dimensional. So I could slice the depth, so I could pick a depth range. I could slice the time, pick a time range. But I couldn't do that with latitude because there's two of them. So what I'm doing here is I'm creating a new chord, and I'm calling it lat and long, and I'm going to give it the values of all the latitudes and the values of all the longitudes. And the way I got those is I said, okay, pick the first longitude, 1, I fix that, fix a depth, fix a time, and get the latitude values, because those latitude values are not changing. It's, I don't know why they made it two-dimensional in this case. It is a regular grid. Pretty sure it's a regular grid. Maybe it's not a regular grid. Probably it's not a regular grid. That's why they did it that way. However, I can get those one-dimensional values, and now I can assign it as new chords, and then I can do this slicing. That makes it a bit easier to get that little bounding box. So now I can select on a slice for this longitude range and this latitude range. So that's my little depth slice. So it's smaller. And now I can take the average over all of that. And I'm going to, so I didn't put depth in here. Notice I'm not selecting a particular depth. So what it's doing is it's going to have all the times, because I didn't select a single time. So there's going to be 4 times, and it's going to be all the depths. And what I can do is I can take that thing. Let's just do it, and you'll see what it's doing here. It's probably an easier way to understand it. Okay, so let's go ahead and do that. So what does that thing look like? Interesting. That was really fast, right? It didn't actually do the work. It is showing you the shape of the thing that you're about to create. To actually do the work, I'd have to do compute or load. But it shows me what the shape is, and you can see it's got 4 time periods and 22 depths. So I see, aha, the lat and the long are gone. I just have time and depth. And now I want to plot that. So I can tell it I want to do a line plot, and I'm going to have the x-axis be depth, and it's just going to be smart and create 4 lines for me. Why did you not want to do that? Goodness gracious. Why? Why? Oh, no, okay, well, it just took its time. Okay, so there we go. And we have the depth at all the lines. So you can see how xarray is making it really easy to work with these gridded data sets. And the data is still on the OPeNDAP server. I never downloaded the data. I'm using xarray to point to the data and then say, hey, I want to do things with that data. Like in this case, I want to get this potential temperature at 4 different dates at different dates. And I'm going out and querying that data and doing that operation, and then it returns the information and plots it. I could also return it to a data frame and save it. Okay. I'm gonna stop here and move on to talking about authentication, because this is something that will really cause difficulties when you are accessing data that's on servers that require authentication. Yeah, let's go back here. Okay, go back to 2005. If you are working a lot with OPeNDAP servers, I encourage you to go through all the examples here. I went through a bunch of different OPeNDAP servers, trying to like go through a whole lot of variants that people run into. And let's see. Okay, so yeah, let's do this. Which one should I do? PyDAP? No. Okay. I guess I'll start with NASA. I have like all of these are different ones that require authentication, and kind of different examples of this. So what I'm about to show you is just one example. Okay. So let's go here. Let me throw you in here. Get back to the chat here. Okay. So that's where I'm at right now. I'm gonna go ahead, open that in Colab. Okay. And so I need to close off that Colab, or otherwise it's going to scream at me. Clean that up. Okay. So we're going to install this. In this case, I'm going to use Earth Access to authenticate because I'm working with NASA data. Okay. And so the way this authentication works with PyDAP is that PyDAP is a package that helps you handle this authentication and helps you make request of these servers and creates like the headers with the authentication information. And you pass in a session. If you go to the PyDAP documentation, it'll show you different ways to create these sessions, different ways to create these headers. And you don't have to create it all yourself. You'll be using the PyDAP functionality to pass in your username and password, basically. That's what's happening. For some things, like in this case, Earth Access, we can get a authenticated session using this function. Okay, so it's that, and now it wants my password. Okay, so now it's created this header, and now I can pass this to request to the NASA OPeNDAP servers. So here I have some data. I have a URL that you can see from the URL that is going to a OPeNDAP server. And let's, fingers crossed, this still works. Oh, no. Let's go back here. Import that. Okay, fingers crossed. Okay, so there we go. So it successfully got the data and passed this authentication to it. And again, fingers crossed here. Nope. Let's see, what do we have here? That. Now what? Darn it. Bad request. Ah, darn it. Darn. What are you doing here? Maybe. Let's see if this is what's going on. I think it may be something else, though. May have to try to get a different one running here. Darn it. Darn. Okay, I'm gonna try a different example. I should have tried that. Tried not to do it live here and see if I can find a different authentication example. Let's try this one, USGS. No, that's still, let's see, nomads. No, that's not two nomads. Yeah. Okay. Let's see if I can go through one of these, so at least I can show you how it works. I'm going to try on the Jupyter Hub instead of in the Colab. Let's see here. Okay, OPeNDAP. Okay. Let's try this. Try this on the Jupyter Hub. Okay. Gonna run that. And let's get that. Okay. Gonna do that. Okay, got it. So now it was able to read it, but now at this point, it needs to go get the data. And we'll see if this works. Nope. Do it. Nope. Darn it. Yeah, it's not liking that URL today. How unfortunate. Let's try a different one. Yep. See if this one works better. This is kind of like it can be a real headache dealing with the authentication piece, and if anything changes on the back end, things stop working. And this is often, I guess this is kind of like the reality of working with OPeNDAP servers with that authentication. It does kind of drive everyone a little bit crazy. Let's see here. Hey, come on. No, come on. Wait. Try it again. Try again. Surely one of these will work. Okay. See, I did have a comment that I was struggling. Okay, let's stop that. Try this. Gonna work? Come on. It's talking. No. Darn. Nope. Will not talk to their server. Okay, we'll try one more. Obviously, need to go through and debug what they changed on the back end about authentication. So let's go here. So if I can get one of these to work, at least I can talk through what's going on. Nope. Nope. All right. Well, so much for that. Something changed on the back end with PyDAP in the last little while. It's trying to it's able to read the data, but it's not able to authenticate. Oh well. Okay. Well, sorry about that. So I was able to show you interacting with OPeNDAP servers where it doesn't have authentication, and I'll have to reach out to the PyDAP guy and ask what changed on his end, why this authentication is not working now. Okay, I'm going to stop there and see, yeah, if you have questions, comments. Stop share. Right. Has anybody here worked with data on OPeNDAP servers much and has worked with it with xarray? Or have seen this? No? Anyone there? Ah, okay. And Josh, when you're working with OPeNDAP from R, are you downloading the data or streaming the data?
I'm normally streaming it in, so just using like Terra or something.
Uh-huh. Okay.
But I'm continuing to try to work with some of these czar data, and I was in that seminar that was given a week or two ago. So I was interested in trying to use xarray more for accessing that and potentially from OpenDAP protocols.
Uh-huh.
So I'd be interested to learn more about how to get the authentication with PyDAP and everything working well, because I'm trying to build out other tools that can visualize and interact with that data more efficiently.
Mm-hmm. Yeah, I'll debug what's going on with the authentication. I was testing the non-authenticated ones before I went online and didn't think that it wouldn't work in the authenticated ones. Um, but PyDAP is still being actively developed, so there may be something that changed on the back end there.
Okay.
Um, so you said you're interested in czar also?
Yeah, I've actually been trying to put together a proof of concept tool that's just run purely in the browser with the like czar layer TypeScript library.
Uh-huh.
And I've been trying to use your paste data set on the node bucket. And I've got something working, but my biggest hang up to potentially just get something like to actually be on a static website is it needs some form of authentication to even access a public bucket. So if I'm doing it interactively from like Positron, I don't have an issue. But if I want to like spin up a whatever, a website or something, it kind of needs some type of server or something to interact with the bucket to give it approval to get the data.
Hmm.
So I've had to do a few workarounds that work fine on my desktop, but if I want to put something up on like a static web page, I need to now come up with a new solution, even if it's like a public bucket. So, um,
I think that may be fixed
okay,
because um we set up that um the bucket where that data is, my paste data. Well, I guess that's which data you mean.
let me see if I have
Um,
the URL. That's the path for it. So I don't know if there's like a different one, and this one's maybe not up to date or something like that. Formatting.
oh, okay. Yeah, yeah. So we set that up so that you can read the data in from websites now.
Mhm.
And I'll show you, like I was playing around with grid look. I don't know if you've seen this.
No.
It will allow you to load any, it says any czar, but actually I've only got um that had success with czar version 2.
Okay.
But basically it is reading just a czar bucket, and you can go around and look at, you know, and mess with it and visualize it. So if you click up here, you can give it your own URL.
Hmm.
And so I have, um, here, let's see if I can. I don't know if this is similar to kind of what you are doing zarviz. Oh, well, here, I'll show you this one. So this is pointing it at some CMIP6 data. I just went and I found a ZAR that's in Google Nod, and I just gave it the URL, and you can see it's immediately able to visualize that ZAR file.
Okay. Cool.
And I think it's not using ZAR layer, but I think it's a similar idea. It's using a JavaScript library called Zarita, which,
Oh, okay. Yeah, I've heard of that.
yeah. But yeah, I thought this was really cool. It was too bad it doesn't work at the moment with ZAR 3. I've tried a bunch of different ZAR 3, but I was able to point it to my ZAR 2 data, and that worked. It's called pages.dev.
Okay. Yeah, I'll definitely give that a try. But yeah, it definitely seems like a nice quick way to at least load stuff in, just given a URL, so that's nice.
Yeah, and I think I get the impression there are a few different approaches that people are using with these libraries that are now out there.